Welcome to talk number 5 and track number 1. Hopefully you all are still awake. If you're not, you're going to be after this talk. This is fun. So let me introduce you to Lev. Lev is our youngest speaker yet. He loves hardware hacking and has always been passionate about cybersecurity. Conveniently, those two fell hand in hand in his presentation of an ESP8266-based Wi-Fi deauther, and he will explain all of that to you in his talk. Please welcome Lev Milushin.
Thank you very much. And now I just want, if any of you guys here are named Mike, is there anybody here named Mike? No one? No one named Mike? Okay, so it looks like we failed our mic check, but we're going to try to continue anyway. So hello, everybody, and thank you so much for coming here today. My name is Lev Milushin once again, and I've recently been employed as the staff training lead at Project Empower, but that's already too much about me, so let's get into what this presentation is actually about. So, interesting. So this presentation right here is about microcontrollers, deauthenticators, and this crazy new thing that, you guys probably haven't even heard about yet, artificial intelligence. So let's get started with what is a deauther in the first place. Oh, I'm in charge of the clicker. I forgot about that. There we go. So what is a deauther in the first place? To understand what a deauther is, we need to first understand how it is that routers communicate, and to do so, how they do so is through frames which encapsulate, frames which are encapsulated inside of packets. And so an example of one of these frames is a deauthentication frame. And what that does is it's essentially a frame asking to disconnect from a router. And so deauthers actually exploit this frame by spoofing an IP of a device, and in the end, it looks like the device is disconnecting from the router, when in reality, it's the deauther that's doing it. And so to the end user, that just looks like, like you're using the Wi-Fi, and all of a sudden it just stopped working, as it tends to do so. But why is this beneficial, right? You might be asking. It's just, it might be, sounds like a harmless prank to play, but we will go in depth as to how and why that is beneficial to hackers. But first, why not just demonstrate, how it looks, what it does, how it works. So this is going to sound a little bit sketchy, but I'm going to ask people to connect to Wi-Fi right now, and it is called, here, let me check it out. BSides deauth demo, anybody who's interested in doing so. And so it's BSides deauth demo, and the password to it is BSides 2.4, all lowercase. And so once I have more than 2 devices, I'm going to start. There we go. So I got 3 devices connected right now, 4 devices. So here I have it, and I'm going to scan all the access points around. And after a second, it should be done scanning the access points. And now I'm going to put my phone down. And to show you guys how I'm not manually booting you guys off of the network, I'm using this thing. And so now I'm going to select my access point. And now I'm going to start the actual attack. And so in a second, you guys should all be disconnected from the Wi-Fi. And could I get any confirmation from anybody that it actually did work? Yeah, cool. All right, so that concludes the actual demonstration. And that also brings us up to, first of all, just a quick clarification. Some of you might be thinking, well, isn't that just a dumb jammer? Jammers are still cool, first of all. Second of all, no, it's not. The difference between the two actually makes one legal, or at least legal-ish, while the other is not. And what the problem with a jammer is that, as you can see here, it indiscriminately just creates noise across a range of frequencies with no control. So basically, you're just creating a field where there's no communication allowed. And the problem with that is that that can do something like preventing an emergency call, and that actually makes them illegal in a lot of places, yes, including the United States. And but besides that, jammers also just look cool as hell. I mean, look at that one right there, it looks like a forest to get lost in, you know? Maybe that's how it is. It's just a forest that Wi-Fi tries to sift through, it can't, you know? So moving on to Wi-Fi deauthers, though, they're a lot more precise in their approach, and instead of, you know, just creating noise across a range of frequencies, they once again spoof the address of a specific device or a specific network. Like right now, I kicked everybody off of the network, right? But if I wanted to, I could, for example, kick a specific device off of the network without being connected to the Wi-Fi. And so, once again, you might be asking, though, why is that like helpful? Why is that beneficial? But before we get into that, I just want to say that, you know, before you guys figured out what to do with it, it is legal to do on yourself with your own devices. It's not legal to do on other people's devices. So I just want to get that, you know, ethical disclaimer out of the way. So let's move on to the illegal stuff that we can do with it by ourselves. So why would hackers deauthenticate? It might seem trivial at first, but there are many reasons to deauthenticate somebody or everybody from a network. One example of this could be creating evil twin access points, which, for those of you that don't know, those are just networks that look like they're the same one that you were just on, but they have something behind the scenes that you don't know about that maybe spies on like everything you send through, or maybe there's a CAPTCHA that you have to complete, or maybe you have to put in a password in like an, what's it called, like a captive page. You guys know what I'm talking about, like when you're connecting to the Starbucks Wi-Fi and it asks you for all that stuff. So that can be utilized, and then there's also something called a WPA pass cracking attack, which utilizes a handshake that occurs when a user connects to a Wi-Fi and inputs the Wi-Fi password. And that we will go in depth right now. But before we do, I just wanted to bring up why the whole Marriott was right there. People that utilize these attacks are actually not only hackers, but there have been some hotels that have utilized these deauthentication attacks in order to boot people off of their free network, forcing them to connect to a premium one. And the FCC has gotten those into trouble with, I believe it was Marriott that had to pay $600,000 for that. So, you know, don't mess with the FCC. And let's move on to WPA pass cracking attacks, get a little in depth into them. But before we dive deep into the art of WPA pass cracking, we need to set the stage with a bit of background. You know, in the vast realm of wireless security, WPA, it serves as a standard. And it's essential to understand all of its roots and variations since, you know, it is a standard, once again. And as a side note, though, by WPA, I do mean like the whole nomenclature, WPA1, WPA2, WPA3. But let's move on to, first of all, WPA1, usually just referred to as WPA, which stands for Wi-Fi Protected Access, and you're going to want to remember that, trust me. And WPA was a badly needed standard patch rolled out across the globe to shield people from the insecurity of its predecessor, WEP, and it had a lot of vulnerabilities, or WEP had a lot of vulnerabilities, which WPA kind of helped. And soon after, more effective methods like WPA2 and WPA3 had been established. And although each had their own set of cryptographic enhancements, they all kind of share like a common DNA almost. And because of this, they all have their own Achilles heel, specifically when it comes to pass cracking, but the methods do vary. But for our deep dive today, we're going to go into the plain old classic WPA. This protocol, despite its age, it still finds its place in many networks, and between you and me, our home router used exactly that until very recently. So, you know, anyways, now that we know that our problem is still very much relevant, let's strap in and get cracking. Yes, pun intended. So WPA password cracking it's kind of an in-depth, complex topic, but it starts by capturing a four-way handshake between a user and an access point. And once again, what that is it's the process of when a user connects to a network, they hash together the name of the network and the password to make a pairwise master key. And that is sent over to the router. And once that is confirmed, you get authenticated to the network. And so, to do that, we need to connect to the Wi-Fi. But when we're doing that, we send over that PMK, pairwise master key, over the web. And this can be, this can be like taken. This can be viewed. Somebody could use something like Wireshark and find that. Or find isn't the right word, like sniff that, that's the right word. And this can be achieved by, just patiently waiting for a user to connect. There is a more fun approach to this, like, I don't know, using some shoddily soldered together piece of equipment, which is held together with a hair tie to maybe boot everybody off of the network. And now you have a bunch of people trying to reenact that handshake. And some of you might be seeing where I'm going here, right? And so once the handshake is in play, tools like maybe CLI tools like AeroDump, NG, or even more sophisticated packet analyzers like Wireshark come into the picture. And these tools allow us to actually capture that handshake. That was the word I was looking for, which is then saved as a .cap file. And quick fun fact, the .cap extension actually stands for capture packet. Neat, right? So here's where the magic happens. The actual cracking process involves generating a series of PMKs, or pairwise master keys once again. And these are derived from the combination of a passphrase and the SSID, or the network's name. So using a word list, we can basically create a bunch of these. And once we have a bunch of these, eventually one of them is going to match up with the one that was sent over, right? And once we get the one that is identical to the one that was sent over, that would be, like, the inputs of that function would be our password. And, we've identified the passphrase. It's kind of like brute forcing, but with the added kind of benefits that you don't have to be near the router, you don't have to even be connected to the network or any network to, the internet at all. And to exemplify this, say that, I'm attending a cybersecurity conference, and I've got a crappy laptop with nothing but Wireshark on it, and I capture the frame, or not the frame, sorry. I captured the pairwise master key that someone uses to connect to the Wi-Fi here, because, let's say there's a premium Wi-Fi here, and I capture that, but my laptop, it can't actually crack the hash. What I could do is I could send it over to a hash cracking rig somewhere else, and what a hash cracking rig is, it's a computer specifically designed to, crack hashes. And once that machine is done, I would have the inputs of the function that actually worked, which would be the combination of, once again, my network name and my password. And so this is getting a little bit wordy, so I'm just going to try to quickly reiterate it in a quick order of events. So first off, the user provides a passphrase to connect to the Wi-Fi network, and then that passphrase and the SSID, or network name, are used as inputs to a hashing function, which the hashing function then hashes the passphrase and SSID combination 4,096 times to produce a 256-bit PMK, or once again, pairwise master key. And the way that this is done means that, once again, we can recreate that exact occurrence. And so that means if we hash together the correct password and SSID, we'll get an identical pairwise master key to the one captured in the cap file. So for example, let's say we've got right here the inputs of password 123 and 1+, which would be the router name in this case. That would make the PMK of 9F, blah, blah, blah. And so now that we have this 9F that we captured from another user without knowing the password, but we know the network name, we could brute force a bunch of these pairwise master keys with the inputs of pass1 at 1+, and then that would give us that. Pass2 at 1+, that would give us the other one that also doesn't match up. Eventually, though, we would get to pass123 at 1+, and that would be identical to the one that we originated with, right? And also, I just wanted to quickly say that if I'm going too fast, or if anybody has any questions at all, I'm pretty sure they figured out the podium mics by now, so just feel free to interrupt me, and I'll try my best to answer any questions that you guys have. But moving on to something else, Wi-Fi Fisher. Wi-Fi Fisher is a vast, streamlined framework of many, many different tools and techniques, which honestly deserves a presentation of its own. So I will try to narrow it down only to tools that are directly applicable here, which are, the phishing elements. Not only is Wi-Fi Fisher capable of creating evil twin access points, but it also has built-in fake captive portals. And once again, to like explain what that is, it's like, if you've ever logged into the Wi-Fi on Starbucks where it asks for your name, last name, email, social security number, name of firstborn baby, your standard stuff. So what we can do is we can exploit that, and we can make a fake captive portal which says something like, oh, there's a critical firmware update and you need to put in the password of the network. And so an unsuspecting user is like, well, okay, I know the password. I can put it in right here. And so this password's put in, and it's redirected to you. And now you have the access to the Charlotte premium Wi-Fi, Oh, and just a quick disclaimer, please don't actually do this. Do it on your own devices. But again, there's so much more to Wi-Fi Fisher, but this is just a specific example use case of it. And I highly recommend that anybody that is interested in that looks into it themselves, because it's huge, it's awesome. But before we move on, I just want to take a look at this beautiful Wikipedia artwork. I mean, look at that. Isn't that beautiful? The jagged lines and then the markup right there, and whatever kind of router that is, that actually looks awesome. And so does the laptop, honestly. I love that. I think that's beautiful. So let's get to the elephant in the room, utilizing this brand new thing called AI and, well, the development of this garbage. The process to create the ESP-based deauther was, of course, long and convoluted, given I had almost no experience. Sorry, so I think there's a bug in here, because I had plenty of experience with all this stuff. I was an expert in both deauthentication attacks and microcontrollers. I have a master's degree, actually, but, Either way, AI such as ChatGPT greatly helped me with this, and I will admit that I didn't think I could have done it without it. No, that's not true. I could have done it all by myself. I just wanted to shorten the wait. So the great thing with ChatGPT is that it's perfect for asking those niche questions, as well as just like cryptic errors that you don't even know how to search for. You don't know where to begin. ChatGPT is perfect for just trying to figure out leverage yourself, trying to figure out where you're going from here, right? And earlier into the flashing process, actually, I received cryptic output, which honestly described my thoughts pretty accurately with question mark, pipe, question mark, exclamation point, question mark, question mark. I could go on and on, and this would have taken me probably hours to figure out before ChatGPT. But when I consulted about it, as you can see here, it immediately suggested that maybe it could be a result of an incorrect baud rate, which is indeed what it was. And if you're curious what baud rate is, that's just in the Arduino IDE, it's when you set your input rate slower or faster than what the ESP or any microcontrollers you're working on. So basically, there's a mismatch of speeds, and now you're getting corrupt characters like that. So if you're working on that, make sure to double check that, save yourself some time, or just ask ChatGPT. But that brings us to utilizing AI, the bad. If you ever worked in any form of customer relations, you tend to know that, the last person to know what they want is the customer, right? And during this project, I kind of was that customer. A good example of this could be the countless frustrating hours I spent with some kind of watchdog error, which caused the single board computer to restart every few seconds. And this error was actually, stupidly enough, due to the fact that I was persistent. I was 100% sure that my board was a generic ESP8266, when in reality, it was a Node MCU board, so I was basically flashing it to the wrong type of board. And this unfortunate lapse in judgment caused me and poor ChatGPT to spend a solid day trying to get around this watchdog, instead of just solving the root cause and pressing 5 buttons to switch it to a Node MCU. So yeah, if later on anybody tries to attempt this or any project yourself, make sure you select the right board. It is Node MCU, not generic ESP. But moving on to utilizing AI, the ugly. Although AI, as we've demonstrated with the countless presentations before me, AI can be used in almost any field, right? It's still important, though, to consider its limitations. And one of the biggest things to consider is that these learning language models, such as ChatGPT, can't truly comprehend things. And what they're more designed to do is coming up with plausible sounding answers instead of more something that's factually correct. And although this is greatly improved in more modern models, such as ChatGPT 3.5 and 4, it still does show its prevalence, especially so if you've never worked with the more outdated models through their API, or if you ask it if 450 is 90% of 500. Has anybody done that? I hear some laughs. What it does is, I mean, even then, like, it can go like, oh no, 450 is not 90% of 500. So what you got to do is you got to do 500 times 0.9, and then that will result in 450. So it looks like you were right. And there's a lot of cases like that with ChatGPT, which it's really important, especially when you're thinking about something from like a math or statistics point of view. It does kind of suck at that, as well as other things. But the biggest issue with AI is its lack of privacy. And while for small personal projects like this little piece of garbage, this e-waste, it doesn't really matter, right? I mean, I don't really care if anybody knows the source code. I mean, I don't know the source code. I copied it from someone else, It does kind of become a problem once you upscale this to maybe a company's cybersecurity roles, and it could definitely lead to some very interesting issues, as demonstrated in the Android ChatGPT leak, where confidential source code was provided to ChatGPT 3 separate times in the span of 1 month. And when consulted about AI retraining data to further train itself, OpenAI answered with a pretty generic statement that, your conversations may be reviewed by our AI trainers to improve our systems. So, don't use it for confidential data, especially if your company has introduced one of the many new tools to avoid this, as shown on the bottom right. And also there is outside by, I believe, Nightfall AI or something like that, which that's actually what their company is exactly like what they're doing. So if you are more interested in that, check that out. And if you're interested in a specific like the implications of AI in cybersecurity, stay tuned, because I believe that our next presenter, Mr. Hutchins, will actually go in depth about just that. So I'm really excited for that. But moving on to defending against these attacks, defending against deauthentication attacks. Does AI come into play, right? Well, now you might notice that while demonstrating the attack, I used my phone hotspot, and I'm not actually sure if I mentioned this, but I specifically used my phone hotspot instead of literally anything else, because my phone, I could limit it to 2.4 gigahertz instead of 5 gigahertz. So you might be inclined to, just get a 5 gigahertz router, Wi-Fi upgrades are always nice. But with all things tech, it's not that simple. And my Deauther is only limited to 2.4 gigahertz due to the actual chip that it uses, the ESP8266. That's limited to 2.4 gigahertz, and this, there's plenty of ways to get around this, and there's several Deauther softwares that can run natively on any computer, assuming the existence of a wireless adapter, which is capable of packet or monitoring mode and packet injection. And I mean, most cards don't come with that, but again, you can get this on Amazon or something like that. I believe I just did not mean to do that. Yeah, sorry. So once again, it's only limited to 2.4 because of the chip, and there are native, there are native things, and I mean, that's pretty much it. But the AI, you could overcomplicate this, and you could try to, I don't know, use AI to check for different things, check for something that looks out of place, maybe data or data streams that don't look like they should be, and you could have AI constantly retraining itself to understand which data streams look normal, which don't. And the problem is, though, you don't know if this AI IDPS, that's a mouthful, would even work. So, there is the chance of, just asking ChatGPT to upgrade your router to the 802.11w standard, which prevents against this specific attack with protected management frames, which encrypt all frames sent to and from the router, meaning spoofing would be much harder. And, that's the end of that for now. There are going to be plenty of exploits after this, but, for now, that's what you got, and that's what we can do. So thank you so much to everybody here today for, letting me blabble on to you. And that's it. And if you are curious in making your own Deauther and you're having some trouble or anything like that, my email does stay open if anybody has any questions at all with that. And if anybody has questions right now in general, please speak up, because this is, the more or less conclusion. So are there any questions anywhere? Let's hear it.
So I have a flipper with a Rogue Master firmware, and if you buy the Wi-Fi dev board, it actually has a PMKID like deauth workflow thing, and it'll actually capture the hashes onto the SD card that you can crack. Have you played with that at all?
No, unfortunately, I don't have a Flipper Zero, but I mean, I've thought about it, but also I feel like it's more fun for me, at least, to build my own versions of these tools to kind of further, as well as like cybersecurity knowledge, also like electrical engineering knowledge. So personally, I prefer something like that, but I do definitely, I think the line of, what are they called? The one you were just talking about.
Flipper?
Yeah, the Flipper series, I think that's super cool, but I personally do not have any experience with them.
Yeah, no worries.
Any other questions? Yeah, the screen is like, so the actual ESP right here, you can see like there's a black section, that's the actual like controlling part, that's the brain of it. And this screen, it's just attached as like a, the firmware, how I interact with this, That's all that is. Any other questions? Go ahead.
What's your preferred workflow for dehashing passwords that are captured?
So I'm about to sound like a poser. I have not actually, I've been so, in-depth into this presentation that I haven't been able to, in the end, actually dehash a password, but I definitely am working on that once I get home.
With most home routers that do adjective, noun, I think it's 3 or 4 digit letter or number, you can generate a custom word list through word list rules, and I believe Hashcat supports the word list generation, so it makes it really easy if you have something that like is lying around and has a default password to test this on.
Cool. Yeah, I'll definitely try that out. That sounds really cool. But before you guys think you're free, there is a pop quiz. So have you guys studied? You all studied, right? Y'all did the homework assignment that other guy told you to do, right? This is how this falls hand in hand with that. So some quick general rules. If you believe you know the answer to a question, raise your hand, and I'll call on the first person I see with their hands up. And you may not earn more than one ESP8266. So starting out with the first question, what does WPA stand for? Anybody know? All right, I saw you first. Go ahead.
C.
C?
Yes.
That is correct. Good job. Come up here and I can get you a prize. But while he's coming up here, let's get to the second question. There we go. Which type of attack involves creating a network that appears as if it's the same one that you were on? I believe I saw you first, so let's hear it.
Is it B, evil twin?
B, it is indeed B. Oh, well, yeah, it's B, so you can come up as well. Here, this is an ESP8266. Yeah. And so now we get to the last question. What does PMK stand for? Does anybody remember? All right. I didn't see anything. I'm not going to lie. I wasn't sure who the first one was, so I'm going to turn around, and then on the count of 3, everybody raises their hands, okay? 1, 2, 3. I don't want to call on you because you're my brother, and you can play with these anytime. So I'm going to do that again. 1, 2, 3. Okay. I think I still saw you first, but I think I saw you truly first. It is indeed Pairwise Master Key. Come up here for your prize. And now there is one last question, bonus question for the display I used actually. So, if anybody's interested. I believe I saw you first. So what does .cap mean? That is correct. Come up here for a little screen. All right. And as a legal disclaimer, I make no warranties expressed or limited, including but not limited to the limited warranties of measurability. The ESP will not cause the end of the world as we know it. Side effects of using it may include but are not limited to seizure, death, rapid combustion, spontaneous human combustion, unspontaneous human combustion, mild irritation, and so on. You can read this on yourself. And exactly. One last thing, if you somehow manage to enjoy listening to me speak about this stuff and have a kid that you want to get into the field There is a great opportunity with Project Empower, and they are basically a volunteer organization for helping students. I believe it's grades, it says up here, grades 3 to 8 of Charlotte learn coding at no cost. And the coolest part is all the teachers there are, you know, fellow tech aspiring teenagers such as myself in grades 9 through 12, just like yours truly. And you know, if you'd like to reach out to them, you can support them at projectempowercharlotte@gmail.com or scan any of the QR codes, and that is going to be it from me. Thank you so much to everybody here. And yeah, give yourselves a round of applause.
Thank you, Lev. And before you all run away, I do have an announcement that I forgot to make before I introduced him. The silent auction. It actually ends at 4:35, not 4:45 like in the program. That was my mistake. Whoops. Also, if you signed up for training and didn't get a training ticket, they are at Reg. If you sign up for the training tomorrow, the workshops tomorrow, you can get your ticket that proves that you actually did it at Reg. So that's all I have. Thank you very much, Lev. That
you very
was
much to you as well.
entertaining as I told you guys. Were you entertained? Were you not entertained? And are you awake? Yes, that's what I thought. You did awesome. By the way, there is no more talks in track number 2. The next talk in track 1 is the next and last talk before closing ceremonies.